I just were to, no. This is going to be a good semester. No. But put it in your binder. Folks, I can promise you things are going to be more structured. Touch, that's right. Hold back, hold back. Dial it in, dial it in. Here we go. Isosceles triangles. How many sides are congruent? Just out of curiosity. Two. Equilateral. How many sides? All. Very good. Recall that the isosceles triangle has at least two congruent sides, and that the congruent sides are called the legs. Fill this in. And I am recording it if you get lost. The vertex angle is the angle formed by the legs. And I abbreviate a bunch, okay? It's the angle formed by the legs. So if you'll look at this, it says the side opposite the vertex angle is called the base. Now, I always like to have my isosceles triangle sit in a certain way. I always want it sitting upright. Now, this picture right here, look at that. Which angle is the vertex angle? Is that triangle sitting the way I like to see it? No. I want that thing sitting up. If I were to turn it, I want it sitting like this right here. That's the way I want that triangle. So it would be 3 up here, 1 here, and 2 here. So angle 3 is the vertex angle. You're absolutely correct. Which two angles are the base angles? 1 and 2. Y'all cool with that? Remember this? Okay? We ought to go through it pretty fast. This is not going to be baby step geometry anymore. Okay? And I'm specifically talking to my oldies. We're going to ramp this up because we should. And I've got to get you ready for a test. So the base angles theorem says that if these two sides if the sides are congruent, then which angles are congruent? Look at that first set of that first triangle. Remember how I told you that it's the sides opposite, the angles opposite those sides? So angle B would be congruent to angle C. Remember that? Remember that? Okay. And then the converse of that starts with the angles. If angle B is congruent to angle C, write this down. Now I want you to be very specific. How would you name which side is opposite angle B? Be careful. Which side is opposite angle B? Side AC, segment AC. Be sure it has a top on it. And then angle C is opposite which side? Side AB. Remember, when we name the sides, it's 2 letters, AB. Or BA, depending upon the way you write the name. Okay? But those are the 2 variations, the base angles theorem and its converse. Comprende? Okay? All right, let's keep on rolling with it. And there are 2 graphics, and they're beautiful, right? Gorgeous. Absolutely beautiful. Here we go. Now let's look at this. Let's think about this. It says the length of segment YX is 20 feet, and it's marked. Explain why the length of YZ is the same. Nuh-uh. Nope. 20 has to do with the side. 40 has to do with an angle, so they don't have any connection at all. What do you think, Daniel?
Because the 140 it already has 20.
Well, what does this form right here, y'all? Be more specific. Oh, linear pair. What do we call it? We call it the rainbow. If we have a linear pair and we've got that exterior angle is 140 degrees, what's that interior angle have to be? It has to be 40. Because we know that 180 take away 140, and I'm going to write linear pair. Everything I write on the board, is that important? Yes. So that means it ought to go in our notes, right? Okay. So that means we got 40. So now we've got two, what kind of angles that are 40 degrees each? What kind of angles? They are congruent. Be more specific. They are acute. Be more specific. Pertaining to this triangle. What kind of angles are they? If that's an isosceles triangle and those two, what kind of angles are congruent, then that means we know what? Yeah. Warm. Base angles. Okay. That's what I was looking for. These right here, folks. If base angles are congruent, move down. Come on now. There we go. If base angles are congruent, then the sides opposite them are also congruent. Meaning, if I were to have 40 and 40, X, Z, Y. And that's 20. Then what can you tell me about YZ? It's 20 feet as well. Because these two angles are congruent. Those two sides are congruent. Does that make sense? If base angles are congruent, then the legs are congruent. And that's just applying that isosceles triangle theorem, okay? Or that base angles theorem. I never know the name of them. I should, but I don't. Okay. Yep. No. That angle on the outside is 140 degrees. This exterior angle right here is 140. Okay? Other questions? These are good questions. Everybody good? Everybody have all that written? Yeah? No? All right, hold on. All right, so let's look at this problem. Find the measure of angle F. How in the world? What are we going to do? We got a triangle, right? Alexis, what's the sum of the angles in a triangle? Sum of the interior angles in a triangle. Warm. Very warm. Take 2 more steps. How much? I want to know the sum of the interior angles in a triangle. What is it, everybody? 180. Okay? What? 180. Triangle equals 180, folks. How am I going to figure angle F? Subtract 22 from 180, and I get 158. Why am I dividing by 2? But the angles aren't marked congruent, but the sides are. If these two sides are congruent, then the angles opposite those sides are also congruent. So I'm going to take 158 and divide by 2. Why am I dividing by 2 and not any other number? Because there are 2 congruent angles, right? What's 158 divided by 2? 79. So that means the measure of angle F is 79 degrees. Y'all agree with that? Facile or difficile? Facile. How about another one? We ready? Okay. If I lose you, you watch this video because I'm going to post it this afternoon. You do this one yourself. What am I going to do? Tell me how to solve this. Kevin, 180 minus 48, which is? What do I do with 132? Divide by 2. 66 degrees, which is the measure of angle H. How many of you got 66? Question? Do you know how to work those calculators? Because they are kind of weird. Did y'all use those or did y'all use Texas Instruments? Y'all use the black calculators? Yeah. I know, everybody does. They're trying to phase these out. After this year,
What's wrong with these?
nobody likes them. You do? Okay. Yeah, we can't graph on them. All right, here's another one. Woo, now we got algebra. Let's look at this. For me, personally, what's wrong with this picture? It's not turned the right way. It's sideways. All right, so I'm going to redraw this. And I'm going to put what letter at the top? I've got to put H at the top because this is when it makes sense to me. So that means J will be here, G will be here. Now, you guys, all you have to do is turn your paper. I can't turn the smartboard, okay? So I've got G is X plus 44. J is 3X, and we've got to find the measure of angle G. Justin, go. Not on this one. Why? Why? Because I have two congruent sides. Do you guys agree with that? If HJ is congruent to HG, then that means that angle G is congruent to angle J. Write this down. And if they're congruent, folks, what do we know about their measures? Their measures are equal. So the measure of angle G is equal to the measure of angle J. This is doing a proof without doing a proof. Okay? Now we're going to substitute. What's the measure of angle G? X plus 44. What's the measure of angle J? 3X. And now what? Now what, Michael? So, I can. Now what? Keep going. Yeah, I can do that. Keep going. Okay. And do what? Right on. Divide by -2. And we get -44 divided by -2, which is what, folks? Positive 22. That's my answer, right? Why not, Lauren? Here's the part. Folks, now let me tell you something. How many of you where do you think this is going to be in your SOL answers? It's going to be the first answer you see, and how many of you would have clicked A? Boom! Don't you do that. Don't you dare do that. Wait. There's more. Go back up to the top. We've got to find measure of angle G. And measure of angle G is what? No, hold up. What is it? It's the X plus 44. And again, we are just substituting. What am I going to substitute in? The X, which is 22. 22 plus 44 is 66 now. Where do you think 66 will be?
B.
It's either going to be B or C. Guarantee it. Guarantee. I would put money on it. Okay? And I'd put a bunch of money that 22 would be A. I promise you'll see this again. Promise, promise, promise. You got to force yourself to slow down. You got to force yourself to use that highlighter tool. Okay? You got to force yourself to slow down. How does this make sense? How many of you got this? Got it, Miss Perry. Here we go. Good, 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 good. That's good. I want you to do this one yourself. Go. What am I going to do to this for me personally? You're going to turn your paper upside down. I'm going to redraw it because I have to. That means M is at the top. N didn't change. P didn't change. 6y, 8y minus 16. Somebody new, tell me how to set this up. Chrissy, how do I set this one up? All right, and how did you solve? 6y? Nope. You have to set it up like this. You do not have to solve it like this. Okay? But yes, it's got to be set up 6y equals 8y minus 16. Now what would you do? And then what, Chrissy? Divide by 8. It is 2 because I made a mistake. Sorry. Minus 2. There we go. Now what are we going to divide by? My fault. Divide by 2. And y is equal to who, y'all? 8. So what you had, Chrissy? I messed you up, I think. Sorry. What was the 8? Where's it going to be in your answers? It's going to be A. It will be A, but are we solving for that?
No, we're solving for the measure.
We're solving for N. So the measure of angle N, what's it say? 6y. Or 6 times 8, which is how much? 48. How many of you had 48 hands up? Rock on, high five. No. Now, why would that not be right for sure? Negative 48. Why is that not right? Because you can't have a negative angle. What? Did you set it up? Yeah, totally fine. That's fine. Okay. Okay. The final answer, y is equal to 8, the angle is equal to 48. Equilateral means all sides. Equiangular means what? All angles are congruent. All right, very good. Do you see it, Daniel? You'll sit at my desk. Oh, it's up here. I'm sorry. I didn't mean to fake. It's behind Chase. My bad. All right, here we go. We have, what kind of triangle is this ABC, the first one? What kind? Equilateral. Because the sides are congruent. And an equilateral triangle, which angles are congruent? All of them. All of them. Angle A is congruent to angle B, which is congruent to angle C. Doesn't matter what you call it, equilateral triangle, everything's congruent. What's this second triangle ABC? It's equiangular. They mean that, well, they do mean the same thing, but it's a way to name them differently. It tells us what's congruent. What's congruent in an equiangular? The angles. All right, so if the angles are congruent, then what do we know is congruent by this theorem? The sides. Side AB BC, CA or AC, right? The opposite sides are congruent. Comprende? Do you agree with me? Yes? All right, so what are we going to do with this? Kinda. It's kind of like that. By the way, equilateral and equiangular triangles, what are their angle measures? 60 degrees. Does it matter, Joseph, what kind of triangle? Does it matter if it's an equilateral or an equiangular? Nah. For both of those, because the sides are all congruent, then the angles all have to be congruent, and 180 divided by 3 is 60. Beautiful. Here we go. How are we going to figure this out? Jade, what do you think? You raised your hand.
No.
Yes, you did. I saw it. How are we going to do this? What kind of triangle is this? Jade, you're throwing your voice again. Stop that.
It's equilateral.
It is equilateral. How did you know? Because all the sides are congruent. If all the sides are congruent, then what?
It equals 180. 60 degrees.
What? What's the little, are you Yoda? Triangle. They all 60 degrees. What? I don't know how to do that. Okay. What? You think you know how to solve it? Jade, how are we going to solve it? Equilateral triangles angles are equal to what? Jade, you're throwing your voice again. Stop it. 68. Very good. All angles are equal to 60, but you also have angle L is equal to 2x plus 32. How am I going to solve for x? Anybody? Jeez. The measure of angle L, I'm going to put that it's equal to 60. We know that the measure of angle L is 2x plus 32, right? Subtract 32 from both sides. 28. 50, 60, yep. Divided by 2, and what do you get? 14 you get. How did you do the problem?
I multiplied 2x plus 2 by 3.
And set it equal to? Why? And all the angles in a triangle equal how much? Attaboy. That's right.
Did he do
Oh.
complicated way?
Not really. He just did it his way. It's not really complicated.
It seems like that's a bit more complicated.
No. You know what he fell back on? His knowledge of triangles. And you will tend to fall back on the information that you're most comfortable with to solve these problems. And that's fine. Very good. Hey, am I done?
No.
Better read a problem. Am I done?
Yeah.
Why? Because I had to find x. And I did. And it's all good, right? Yeah. Why would I find the measure of angle L, M, or K in this? Because they're all the same. We already know they're 60. Hey, do this one. What kind of triangle do I have? Be careful. Why is it equiangular? The circle things. You know that the circle things will never be an option on the SOL, right?
Yeah.
Okay, just making sure. Congruent marks. That is triangle. Then what do you know about its sides as well? Sides are equal to. Write this down. The sides are equal to. So if the sides are equal, then I can say that segment NO is congruent to segment who? OP or PO. No, it's congruent to PO. Now what? NO is equal to PO. Do you remember what definition said that we can go from congruence to equality? Just out of curiosity. Yes, sir. Definition of congruence. What is NO, folks? Talk to me.
5y minus 6 equals 4y plus 4.
Is everybody cool? Yeah? And then how am I going to solve it? Add 6 to both sides. And that's going to give us 4y plus 18. Now what? Subtract 4y. Do I have to solve this algebraically this way? What if I solve it differently, but I still get y equals 18? Is that all right? Yeah, that's fine. Am I done? Yes, thank God, right? Yes. Woo! All right. Questions at all? We're rolling, y'all. Do this one yourself. Go. I'm going to give you 1 minute. What kind of triangle is this? Tell us what kind of triangle. How come? Because angles are congruent. Equiangular triangle. All right, here we go. If the angles are congruent, what do you know about all the sides? The sides are congruent. So that means that I can say JL is congruent to KL, correct? That means, because of the definition of congruence, that those two sides' measures are equal. You with me? That also means by substitution that I can say that JL is what? 2t plus 1, which is equal to?
4t minus 8.
And I'm going to subtract 2t from both sides. And then I'm going to add 8 to both sides. And I'm going to get a decimal, yes? And I'm not going to freak out because I'm going to get a decimal. Did you get 2 and a, yep, 4.5? And I'm done, right?
Nope.
Why not? I got to find JL. JL is 2t plus 1, which is 2 times 4.5. What's 2 times 4.5? Plus 1. Ooh, here's a good question. How many of you had 10? Raise your hand. Excellent. All right. Extension to this problem. Extension. Write this down. What's the perimeter? Because this problem might be given to you this way, and instead of finding T or JL, it may say find the perimeter of triangle blah, blah, blah. Add what? Add 10. 3 times Y. What? Yes, it is 30. It is. Right on. Very good, very good, very good. This is a type problem you're going to see right here. This is hard. This is not. This is so easy. You're right. Hey, what's this? Find the value of x given angle D is given, congruent to angle F. No, it kind of looks like a proof, but it's not. What's this mean, Daniel? Okay, hold on. First of all, I got 2 congruent angles, right? Angle D is congruent to angle F. Do you guys agree with that? How do I know that? Because it's given. It says given. All right, so that means that I have, or what can I determine about these sides opposite those congruent angles? They are congruent. Right. Base angles theorem. Write this down. Base angles theorem says if angle D is congruent to angle F, then EF will be congruent to ED. Write this down. Don't you go to sleep. I'm going to shoot you with a rubber band. Not really. I would never do that to a student in my classroom. EF. EF is x plus 3. ED is 12. Solve by subtracting 3. X is 9. Right on?
I put like if angles D and F are congruent, say 10 D and E are congruent,
9 plus 3 is 12. Hey, did we find the excuse me? Did we find the value of x?
Yes, we're done.
Yes. Are we done?
Yep.
Yes, we're done with this. Oh, yes. Yes. Woo! Look at there. Huh? Y'all did awesome. And look, you got 25 minutes. Shh. Listen. No, you weren't. Your voice came this way. Listen. We did a whole set of notes. You have 25 minutes left to work on homework. Get the books open. Let's look at 277.
So do we have to do number 34?
I would try it. I would try it. Because, guys, listen, please. Don't you get your booty up. Don't you. Nuh-uh. That flower baby, flower child. Get that flower child. That's not his responsibility.
We wanted to.
No. Cody.
So officer's baby, they're just gonna up and take it. Oh, well,
All right. Let's look at 277 real quick, guys. Folks, 13, you're using isosceles angles, isosceles triangles. But folks, you may have to use vertical angles as well. Use what you know. Everything is building upon itself here. Well, hold on. Let's look. That was 13. Let's talk about 14. Do I know for sure that T is a 90-degree angle? No, do not assume it. Okay? Draw it without those two, that RT in the middle, and then find the appropriate angle, okay? Look at 16 through 20. 16 through 20 is like the problems that we did today in our notes, but there's a twist. What's the sum of the angles in a triangle? What's that total? 180. So if you look at number 16, notice that you only have one base angle measure. So what's the other base angle measure have to be? That same thing. So you may have to take one angle plus another angle plus a third angle and set it equal to how much? 180. Look at number 17. Same thing. What kind of triangle is 17, 18, 19, and 20? They're equilateral and equiangular. Those are easy triangles to work with, okay? Flip over to 28. Sweet. Little puppy dog. 28. Oh, 28's using parallel lines. It's got an isosceles triangle. You got to know about triangles. You can do that problem. Think on that problem, folks. Help each other. Don't rely on me to spoon feed this information to you because you know I'm not going to. Okay? Work on it together. 34. You can totally do that problem. It's not that big of a deal. Attaboy. We'll tape it. Work. Use your time wisely.